Hey guys, how's it going? Back at it again here with Chapter 3. Now we are talking about sections 3.3 and 3.4. So although we went to Chapter 3.5 on the previous video, we're kind of backtracking here because we're taking a little bit of a different concept approach here to the previous few things that we've been talking about, which deal with parallel lines and the certain types of angles that were given according to those parallel lines. But now we're actually going to identify more so through an algebraic perspective on how to identify parallel lines given other pieces of information, not just through their specific angles. So in today's lesson, we're going to go ahead and find the slopes of lines and use the slope to identify parallel and perpendicular lines in a coordinate plane. All right, so let's go ahead and get started right away. So let's see, first off, it says the steepness of a line can be represented by a ratio called the slope of the line. The variable used to represent slope is m. Okay, so we're going to go ahead and say that slope is m, and all it really is a ratio that represents how steep a line is. And I'm sure you guys have already seen these in your geometry, or I'm sorry, in your algebra classes before getting to geometry. But if you haven't, that's a quick little definition of how we can identify the steepness of a line. We call it slope. Okay. More specifically, however, and through an algebraic view, we can calculate a slope by looking at any 2 points on a line, okay, and finding how much it rises from one point to the other over how much it runs or moves left and right from that same point to the other. So we actually are going to use this formula quite a bit. y2 minus y1 equals x2 minus 1. And again, those numbers come from x1, y1, so my first point, so point number 1, and point number 2, we're going to go ahead and respectively call x2, y2. Okay, so we take y2 minus y1 to find out how much it rose or fell, and then x2 minus x1 to see how much it shifted left and right. So let's go ahead and take that formula that I just highlighted there and go ahead and calculate the slope of my line here. Now, you can do it one of two ways. You can actually take the points and find their order pairs, or you can go ahead and just count it right off of the graph. So the first thing we want to find is the rise. So let's go ahead and find that. So from the point on the left to the point on the right, I went up 1, 2. So that is a positive 2. And I ran to the right 1, 2, 3, 4. So 2 over 4. And in this particular case, that actually reduces. So the reduced form of that is 1/2. And if you're not sure how I reduce that, these both have a 2 in common. So if I divide each of those by 2, I get 1/2. Okay, let's go ahead and do number 2. And again, guys, just as a kind of rule of thumb, if you move upwards, you're going in the up direction, so it's a positive number. And if you're moving to the right, that is also a positive number. And that's exactly why we always start counting from the point on the left to the point on the right. So from the point on the left to the point on the right. So that's exactly what we're going to do here. All right. So what do? I went up 1, 2, 3, 4, 5, 6. I went up 6, and I went to the right 1, 2, both positive numbers, and that will reduce to 3 over 1. Okay. Again, they both had a 2 in common. So if I divide both of those by 2, I get a 3 over 1. And I'm going to leave it as 3 over 1, not just write it as 3, just because we define it as a ratio. So I always like to keep it as a fraction like that. But what I want you guys to go ahead and try is number 3 next. All right, so go ahead and pause the video at this time and go ahead and try out example number 3. All right, guys, if you had a chance to look at that one, you should have, again, gone from the point on the left to the point on the right. Should have gone down 2. That would mean a negative 2. And then to the right, 1, 2, 3, 4, 5, 6, 7, 8. Positive 8. That also reduces because they're both divisible by 2. So it reduces to negative 1/4. Notice all of these are fractions, and the reason why is because slope is a ratio, one number above the other. Okay? This is where our formula is going to come into play. That's the reason why I helped you guys define it at the very top. So let's go ahead and see what we're being asked. It says find the slope of the line that passes through the given point. Write your answer as a simplified fraction. So once again, just to recap, my formula is m, which is slope, is y2 minus y1 over x2 minus x1. Keep that here on the side, just so we know what it is. And this is my recommendation to all of you. Go ahead and write x1, y1, x2, y2 underneath both points. This is going to help you keep everything in order, guys. That way you know what you have to put in the top row of your fraction and then in the bottom row of your fraction. So this is actually going to be negative 1 minus 3, okay, over x2 minus x1, so 6 minus, and notice that's a negative 2. So it's 6 minus a negative 2. So negative 2. But we know that if we have two negatives next to each other, they will actually turn into a positive. So this is really going to be negative 4 over a positive 8. That once again reduces because they have a 4 in common. So this will reduce to negative 1/2. That is our slope. Okay, so again, I just used our formula. I went ahead and followed all my steps. I wrote x1, y1, x2, y2 underneath my 2 points, and that helped me make sure I was doing this correctly. So I'll do one more with you guys, and then I'll have you guys try out the last one on your own. So, and this one is y2 minus y1. So once again, negative 8 minus, m equals negative 8 minus, and I can write it over, negative 8 minus a negative 4 over 2 minus 5. Once again, I have two negatives next to each other here, so they turn into a plus. So negative 8 plus 4 is actually a negative 4. And then 2 minus 5 is a negative 3. Okay. Notice I have two negatives, one in the top, one in the bottom. Anytime you're dividing or multiplying two negatives, really just turn into a positive. So this is really just 4 over 3. Okay. That is 4 over 3. Alright guys, I'm going to have you guys try out number 6 on your own, and I'll just go ahead and write the final answer for you guys. Alright, so if you tried out number 6, you should have gotten an answer of 3/8. If that's not what you got, make sure you go back and look at your formula, make sure you applied all of your steps correct. Alright, so let's go ahead and zoom out here. Alright, so next thing. We have a new postulate here. It says the slopes of parallel lines postulate. Alright, and it says in a coordinate plane, two non-vertical lines are what? Well, if you haven't learned this already, this is going to be new for you, but some of you guys might already know what it is. So hopefully you know what it is, but let's go ahead and read through it again. In a coordinate plane, two non-vertical lines are parallel if and only if they have what? Again, So just by looking at those lines, you might have already known that they are parallel, but there's a reason why. And the reason why is because they have the same slope. Okay? So, parallel lines have the same slope. Right? If that doesn't convince you, let's look at these two lines on the side. We know that both of those are parallel because they look parallel. So let's go ahead and figure this out. If I go down 1, 2, 3, 4, down 4 over 2, my slope is negative 4 over 2, or in other words, negative 2 over 1. How about this other one? 1, 2, 3, 4. Again, a negative 4. 1, 2. So negative 4 over 2 once again reduces to negative 2 over 1. These two are exactly the same slope. Okay, so that's just one way to prove that we do have parallel lines. If you're given a coordinate plane, you can always prove that two lines are parallel by finding their slopes. And if they are equal, if they are the same slope, then they're definitely parallel lines. Right, now we have a slope of perpendicular lines postulate. Okay, so now we're talking about perpendicular lines. So in a coordinate plane, two non-vertical lines are perpendicular. If and only if their slopes are, and again, you might have learned this from algebra, but if you didn't, it's only if and only if their slopes are opposite and reciprocal. Or if the products of their slopes is -1. That bit you might not have remembered from algebra, but if you do, that's great. But just to know that if and only if slopes are opposite and reciprocal, or opposite reciprocals, whichever one you want to say. Okay, but that is the condition. If it's just opposite and not reciprocal, then that's not perpendicular. Or the reverse of that is if they are reciprocal but not opposite, that means they are also not perpendicular. So again, just by using these lines that we have here on our diagram, let's see if we can find if that's true. Because notice the little box here, that's stating that those two make a 90-degree angle, meaning they're perpendicular, like we learned in the past. So let's prove it. Well, on this first line, I go up 1, 2. Remember, rise over run, so go up or down first, then to the left or right. So I went up 2, 1, 2, 3, 4. So my first slope is up 2 over 4, which will reduce to 1/2. Okay, and my second slope from here to here is going to be 1, 2, 3, 4. So 4 down. So my second slope is 4 down, and to the right 1, 2, which will actually reduce to -2 over 1. And let's see if it satisfies both conditions. Are they opposite signs? Is one of them positive and one negative? Yeah. And then finally, are they reciprocals, meaning the flipped version of the other one? And yes, one is 1 over 2, the other is 2 over 1. So yes, these are definitely opposite and reciprocal. So again, just as a little cheat sheet for you guys here, opposite means opposite signs, meaning positive or negative, and reciprocal just means the flipped version of the other one. Okay, all right, let's go ahead and move on to the back. So problem number 7 says line J has a slope of 4/2. Line K has a slope of 2 over 1. Is J parallel to K, yes or no? Well, first of all, what I noticed right away on line J, or rather the slope of line J, is you can reduce that. These both are divisible by 2, so this is really 2 over 1. Okay, so line J has a slope of 2 over 1. Line K has a slope of 2 over 1. Well, they're the same slope, and it said on our parallel postulate that if we have the same slope, then they are parallel. So are they parallel? Yes. Yes, they are. Okay. The next one says line J. So let me write it in here. Yes, yes, they are. So line J has a slope of -3/5. Find the slope of a line K which is perpendicular to line J. Okay. So the slope of line J is -3 over 5. And this is what I always like to do to find a perpendicular slope to that. Okay. First I go opposite. So what is the opposite of negative 3/5? A positive 3/5. And then from here I go reciprocal. And what's the reciprocal of 3/5? 5/3. So the perpendicular slope to negative 3/5 is 5/3. So line K must have a slope of 5/3. Okay. So I hope it's starting to make a little bit more sense, guys, but definitely keep that in mind. That's one thing we're definitely going to have to know, not only for geometry, I mean later on, advanced algebra, algebra 2, college algebra, pre-calc, anything like that, calculus. You're going to need to know those small characteristics of parallel and perpendicular lines regarding their slopes. Okay. Okay, now we're going to move on to something that hopefully is a little bit more familiar territory to you guys, and that is slope-intercept form of an equation of a line, right? This is usually something that most people recognize, the y equals mx b. There's just a few things that we need to make sure we remember what they are or what they stand for. Well, we just said a little bit ago that m is the slope, and look at the rest of the name, guys. Slope-intercept form. That means this other thing here, that b, has to be an intercept. More specifically, it's y-intercept. Okay, and remember, it's a y-intercept. Ends with a pt. That means it must be a point. So we have to write it as an ordered pair. Okay, so let's go ahead and look at a few of these, and then I'm going to have you try a few on your own. All right, what is my slope on 9 through 11? Let's see. Y equals mx plus b. So my slope must be -4 or -4/1, whichever one you want to write. And my y-intercept, my b, again, you have to write it as an ordered pair, is 0, 3. Okay, remember where y-intercept is on a graph, guys. It's right on the y-axis, so it didn't move left or right. So it's still on 0 for x, but my y value is at 3. Okay, all right, next one. We have y equals mx plus b, but wait a minute, there's no b here. Well, why can't I do that? If there's no b, that doesn't do it any harm if I write plus 0. So what is my slope? My slope is 1/2. My y-intercept is 0, 0. All right, go ahead and pause the video real quick, guys, and try out number 11, please. All right, so try number 11. Once again, guys, you can always write y equals mx plus b right above it or right underneath it. That'll help you tell you which one's which. That's your m, that's your b. So your slope here was -2/3, and your y-intercept is 0, 3/2. And I know and I realize that we usually wouldn't give you fractions for your b value, but it might happen from time to time. All right, so hopefully you got those answers correct, and we can move on towards the final few things here of our 3.3, 3.4 section. Okay, now this is going to take a little bit more work, but it actually won't be too bad. Number 12 through 15 say, name the line that matches each description from the given figure. Okay, so we're talking about perpendicular and parallel lines here. So chances are we're going to have to make use of what we just learned. That would be opposite reciprocal slopes for perpendicular and same slopes for parallel lines. All right. So what I actually want to go ahead and do is on the side here, I'm going to actually go ahead and find the slopes for each of these lines. All right. So let's take a look at all these blue lines that we have on the right and find the slopes for every single one of those. All right? All right, so let's go ahead and do that. So I want to know the slope for line N, the slope for line L, the slope for line P, the slope for line Q, and the slope for line R. Okay, did I miss any? N, L, P, Q, R. Nope, that's it. All right, now in order to not make this super complicated and so we don't scribble all over our diagram, I'm just going to go ahead and count using my points. So here I'm going from the point on the left to the point on the right on N. So I went down 1 to the right 2. So 1 over 2. For line L, I'm going from this point to, actually there isn't another good point there, so I'm going to make this my point. So from this red point to my green point, I go down 2 to the right 1. So negative 2 over 1. Line P, what are 2 good points? All right, they're right there. This one and this one. So I go up 2, right 1. Remember, rise or fall first and then run. And then my slope for Q, let's see. This one and this one are good. So up 1, right 2. And then finally, what's a good one? What's a good one? Right here. That's my R. So I go up 1, right 3. Actually, I just noticed I made a quick mistake here. Sorry, guys. On line N, I had to go down 1, right 2. So this is actually a negative. Okay? So there are all my slopes, and actually they are all different. Okay? So I have negative 1/2, negative 2 over 1, positive 2 over 1, positive 1 over 2, and finally 1/3. So keep those in mind for when we go ahead and solve 12 through 15. So it says perpendicular to y equals negative 2x plus 4. So I want a slope, or I want a line that is perpendicular to that line, negative 2x plus 4. Well, what's my original slope here? My original slope here is negative 2 over 1. So I'm going to call this MO, my original slope. It's negative 2 over 1. That means my opposite reciprocal slope, because it's perpendicular, so opposite and reciprocal slope, has to be what? It has to be 1 over 2. Well, which line has a slope of 1 over 2? And the line that has slope of 1 over 2 looks like it's this one, line Q. So line Q is the line that is perpendicular to y equals negative 2x plus 4. Right? Let me do one more, and I'm going to have you guys try the other two. Next one is parallel. Right away, I'm going to go ahead and write same. So I want a line that has the same slope as this line, and this line has original slope of negative 2 over 1. So what other line has a slope of negative 2 over 1? That would be line L. So line L has a slope that is parallel, or is a line that is parallel to y equals negative 2x plus 4. Again, notice I'm not even looking at my y-intercept, guys. That really doesn't matter. What we want to know is the slopes, and the original slopes that you're given have to meet the criteria. Same for parallel, opposite and reciprocal for perpendicular. All right, go ahead and try out number 14 and 15, please. Okay, so number 14 said that it was perpendicular, so opposite and reciprocal. and my original slope that I'm given is 2. In other words, it is original slope is 2 over 1. So my opposite reciprocal must have the opposite sign, so a negative, and it must be the flipped version, so my opposite reciprocal slope has to be negative 1 over 2. And which line has that? Looks like it's line N. So line N is perpendicular to y equals 2x minus 1. And then finally, we want something parallel, so same to y equals 2x minus 1. Again, my original slope is 2 over 1, and if I want something with the same slope, and I also want something with 2 over 1, and it looks like line P would be my winner. So line P is parallel to y equals 2x minus 1. Okay, so again, guys, if for some reason some of that didn't make sense, please go back to the very top, look at your postulates. It states that lines that are parallel have same slope, lines that are perpendicular have opposite reciprocal slopes, and please just look back to see how it is that you can find those particular slopes. Okay? Alright, what we're going to do for our closing activity here is going to be not too bad, actually. I think it'll be alright. I think we just have to make sure we understand and remember how to calculate slope. First off, before we even get started, I'm going to write my slope formula. It's always good to write any formulas that you're trying to remember over and over again. That'll help you guys a little easier. Okay? Alright, so let's go ahead and take a look at number 16. So it says find the slope of AD. Well, I need A and D. So that'll be my x1, y1, x2, y2. So if I set them up, my slope is going to be, and again, I'm going to call this x1, y1, x2, y2. So it'll be negative 10 minus 5 over negative 6 minus 3. It gives me negative 15 over negative 9. Both of those have a negative 3 in common. So this will actually just reduce to 5/3. And if it helps, guys, you could just type that into your calculator. You should end up getting the same answer. Okay. Now I want a line that is parallel to CD. So first off, I need to find what my slope is for CD. So C and D. So once again, x1, y1, x2, y2. Let's figure this out. That would be negative 10 minus a negative 2, and negative 6 minus 4. This turns into a positive, so this is really just negative 8 over negative 10. Okay. And this, once again, they have a negative 4 in common, so they reduce to just 2 over, oops, my bad. Not a negative 4 in common, they have a negative 2 in common. So this turns into 4 over 5. So 4/5. And now, remember, it sets slope of a parallel. So it has to be the same slope. So if this is my original slope, my parallel slope has to also be 4/5. That's why I went ahead and just wrote it right away. Okay. All right, number 19. I want to go ahead and do that one with you, and then you guys will finish the rest. All right, number 19 says the slope of a line that is perpendicular, so opposite and reciprocal to AE. AE. So once again, x1, y1, x2, y2. Let's go ahead and do it. So 9 minus 5 over 0 minus 3 gives me 4 over negative 3. So my actual slope is just negative 4/3. Okay, but look what it said. It said I wanted something opposite and reciprocal. to that. So in other words, I want something perpendicular to that. So my opposite reciprocal slope, in other words, my perpendicular slope to that would be the opposite, so a positive 4 over 3, but also the flip version or the reciprocal. So really I want 3 over 4. All right. So I think you guys should take the rest of the time here to go ahead and try numbers 20 and, oh, I've totally skipped number 17. So try 20 and 17 on your own, and then we will go from there. All right, guys, let's go ahead and take a look at number 20 to finish up today's video. This one says, find the slope of a line perpendicular to AB. So once again, perpendicular means opposite and reciprocal. So we are not quite done once we find the slope of AB. We still have to find its opposite and reciprocal. So let's erase this. We're concentrating on A and B. So x1, y1, x2, y2. So that is, let's see if I can capture it all here. So that would be 7 minus 5 over negative 1 minus 3. 7 minus 5 is 2. Negative 1 minus 3 is negative 4, which reduces to negative 1/2. Now, that's not quite it because we want something that is opposite and reciprocal. So opposite of negative 1/2 is a positive 1/2, but the reciprocal would be a 2 over 1. So my perpendicular slope here is 2 over 1. 2 over 1, or if you just wrote 2, that'd be fine. It's just that you'll notice I keep them as fractions. And then finally, number 17 that we kind of skipped. You can take a quick look at that one. That one just wants to know the slope of BE. So very simple. B and E, x1, y1, x2, y2. It doesn't matter which one you call x1, y1 and which one you call x2, y2, guys. Just keep it pretty consistent. I just picked the first one I see. So from the left to the right, I just picked that one as x1, y1, and the second one as x2, y2. So if we do that, I'm going to go ahead and get 9 minus 7 over 0 minus a negative 1. This turns into a positive, obviously, because I have two negatives next to each other. So 9 minus 7 is 2. 0 plus 1 is just 1. So my slope here is 2 over 1. Or if you wrote it, it's just 2. Either of those two is correct. Okay. Alright guys, I think I'm going to go ahead and end the video here for today. If anything still is a little bit fuzzy and you don't quite understand it just yet, just make sure you go back and rewatch any part of this video. But just make sure that you do, because we want to make sure you have a solid understanding before any test or quiz that you might need to take. Okay. So again, any other questions, please make sure you contact me, you get a hold of me. Ask your teachers, ask any of the math aides, anybody in any of the resource centers. They will be happy to help you. All right, guys, that's it for me today. So I will talk to you guys later. Bye.